This is our third problem from our foldable. We have the function h of t equals negative 16t squared plus 16t represents the height in feet of a horse t seconds after it jumps during a steeplechase. So let's do like we always do. We have height in feet and time in seconds. So let's label that this is height and that these are both time in seconds. We want to keep those units as part of our problem so we know what we're finding. Question A says, when does the horse reach its maximum height? Well, we know that the horse jumps up and it comes back down to the ground. Since C equals 0, that means it's starting at the ground. You know, it's jumping up and it's landing on the ground. It reaches its maximum height right here at the vertex. So we need to figure out at what time it hits that. And that's our negative b over 2a. So for question A, we're going to say when, that's time. So time equals negative b over 2a. So negative 16 over 2 times negative 16. Negative 16 over negative 32 is positive 1/2. And what's our units for time? Seconds. So 1/2, after 1/2 a second, it's going to reach its maximum height. So that's answer number 1. Can the horse clear a fence that's 3.5 feet tall? Well, here's the question. So where does that 3.5 feet hit on our graph? Well, you know, if it's down here, then our horse can certainly clear it. But if 3.5 is up here, he can't. So what we need to do is figure out what is that maximum height, and is it below or above where the fence is? So let's find the maximum height. Height is found by doing the h of t equation, and we know it's going to hit its max height on the axis of symmetry after 1/2 second. So negative 16 times 1/2 squared plus 16 times 1/2. Remember to do your exponents first, so this is going to be negative 16 times 1/4 plus 1/2 of 16 is 8. Negative 16 times 1/4 is negative 4 plus 8 equals 4. What are the units for this? Well, it's height, so it's 4 feet. So can the horse clear a fence that's 3.5 feet tall? Yes, it clears it by 1/2 foot. The last question is, how long is the horse in the air? And there's a couple of ways to solve that. The first way I want to look at is, we know that this amount of time right here is 1/2 second. And we know that this is a line of symmetry, so this has to be the same length. So this is also 1/2 second. So how long is the horse in the air? 1 second. That's how long the horse is in the air. Another way to do that is to say, we know that it starts out at 0. If we can find this x-intercept, then we can figure out whether or not we can find that maximum time. So let's move our fence down now that we know it's about right here. I'm going to say our equation is h of t equals negative 16t squared plus 16. We want to know, 16t. We want to know when he gets back to the ground, and so we know that that has a height of 0. So I'm going to plug in a 0 for height, negative 16t squared plus 16t. We did one like this just a minute ago. We just factor to solve for t. They have a common factor of 16t, so I'm going to take out a negative 16t, which leaves me with t minus 1. So t equals 0 and positive 1. Well, 0 was when he started, so the 1, that's this x-intercept, so he's been in the air 1 second. And you'll see we got the same answer either way we did it. And that's the end of the third example.